Today we're going to be building this 9-to-1 UnUn that we're going to use in our next video with a random wire antenna. A 9-to-1 UnUn is made to match a 450 ohm antenna to a 50 ohm radio or tuner or amplifier, whatever you're going to be connecting it to. When I first saw one of these, I thought it looked rather complicated since it uses the windings like it does, the 3 wires. But once I got into it, like a lot of other things, it's not as complex as it sometimes looks. So stick with me to the end. By the end of this video, I think you'll be ready to build yours as well. This particular UnUn is built on an FT240-43 core. The 240 just means it's 2.4 inches wide. The 43 is the mix of materials that it's made from. I'm using 16 gauge solid wire, and I'm using 3 different colors. And that's just to ease the process of building this, because the way they need to be connected in order to work properly. When we get through assembling the UnUn, we're going to do a test, one using a 450 ohm load to see how well it matches to that, and secondly we'll be doing a back-to-back test for insertion loss. So let's get started on the build. Okay, as I said, we'll use a 240-43 toroidal core. I'll have the link to this and the wire, everything down in the description should you need to buy supplies. Be a convenient link for you to use. If you do buy through the link from Amazon, I do get a small commission, but it doesn't affect the price you pay. You pay the same price regardless whether you buy it through my link or some other way. Again, it's 2.4 inches in diameter, and we're going to be using 3 different wires that I've pre-cut. Now, I found that 24 inches is probably enough, but I've cut them a little longer. These are 26 inches each, and I'll probably be needing to cut some off once we get ready to mount it. But it's better to have a little bit too much than not enough. It's hard to add wire, it's easy to take it away, and just a couple inches here and there is not going to make a difference overall. And I'm going to wind this one the same way I wound the other one that you saw, and we're going to go yellow, green, blue, and get them evened up here pretty well, and put a 90-degree bend in it, and that'll give us our starting point. We'll slip them through, and then we'll get a zip tie to hold them in place so we can wind it. Get this through and get it started. Kind of hard to do that with one hand. I mean, it is possible, but all right, get these lined back up. Yellow, green, blue, like so. And then we'll pull the zip tie tight. And that's just to hold them in place while we're wrapping the toroid. Okay? We've got to go 9 turns. So it has to go through the center 9 times. That's what constitutes a turn. It's when the wires pass through the center. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so let's go ahead and do that. What I found, you want to make sure your wires stay in the same sequence. It's critical that the wires stay in the same sequence. You don't want to cross the wires. And then you can push them through with your thumb, get them started, and then pull them. It's a little more difficult working with 3 at a time as far as the strength required, I suppose. But I wound the other one wire at a time, and I wasn't sure if I liked that process better than this. Once I get through with this, I'll let you know which way I prefer. But I'm going to try wrapping 3 at a time. and see how it goes here. But again, just pull it through, pull it tight. You notice the spacing on this one here. It's about 3/8 of an inch in between on the average. You need to try to keep it about the same, but it's not that critical. So I'm going to try to do the same thing here. Push it through with my thumb. Got to have pretty good thumbs. Hope you have arthritis. This may not be the way to go, or unless you use something else to push the wires through with rather than your thumbs. Okay. I like the way the wires are staying together tight. When I wrapped them one at a time, it seemed like they always wanted to be space in between the wires, but this seems to be going better. Okay, so we've got 1, 2, 3, 4, 5. This will be number 6. Again, we're going for 9 turns. Just 2 more here. That's 7. And we can work on how close these turns are. The wires are pretty much going to touch here in the center. I don't think that can be avoided because of the diameter of the wire. Again, this is 16 gauge solid. And with the diameter of the wire and the thickness of the insulation, it's almost impossible not to have them touch in the middle. And we can work on the spacing of these a little bit once we get them wrapped. I know I make some awful faces when I'm working, concentrating, pulling on stuff, stick out my tongue and various things like that. But I don't get to see you when you're working on stuff, so you may do worse than that. All right, so with an odd number of turns, one set of end of the wire is going to be on the top, and the other end's going to be on the bottom. So I think we're at 9 turns now, so let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 turns. And we can work on the spacing here a little bit, you know, just by pulling on the windings a little. Try to even it out some. Let's see how that's looking. Not bad. You can take some pliers. These don't have very minimal teeth on them, so that they don't tend to damage the wire. And you can straighten them up a little bit if you're so inclined. I don't think it's going to affect the performance one way or the other, but some people like to go for the looks. Okay, so that's looking pretty good. You want to double check your work. Make sure that you don't have any of your wires crossed in the process. And we'll cut these off to length here once we get working with it. So I think we're pretty decent shape there. All right, we're going to make it look like this one. And this is how we're going to wire it. See, we've got the yellow. I'm going to go ahead and put a zip tie on that just so it stays in place, because we're going to be pulling on those wires here shortly. Okay. That's going to work. All right. So we've got our yellow wire, which is going to go to our antenna. We've got our green wire, blue wire, and we've got the yellow, green, and blue here on the bottom. Now, in order to keep track of these and just help in the explanation, these on top here are the number 1 windings, you might say. So this we're going to call this one A, this one B, and this one C. So this will be A1, B1, and C1. This is going to be A2, B2, and C2. And it might help you keep track here. And you can take a screenshot of this and print it if you want to make one, if this will help you. But that's one way to do this. Others have done it this way. I thought it was a good idea, so I copied their idea. Hope you'll copy mine. But it just takes a few connections. And what we'll do here, we've got B1, which is the green wire, that needs to connect to A2, which is the yellow wire. So we can bend that down a little bit and bend this over a little bit. And then we can cut them off where they have a little overlap. There and there. So we've wasted 3 inches of wire, maybe. All right, so we need to strip off the insulation. And what am I going to use today? Let's see how this will work here. I'm going to get this wire out of my way and cut off, 3/8 to 1/2 inch of insulation to give you enough wire to work with. All right, so we got that one exposed, and we get the yellow wire here. Bend these out of the way a little bit. And make some more faces. Get this insulation off. Okay, so we've got the insulation off of those two, and we can bring them together. And straighten them up a little bit. All right, so there's those 2 wires there. So we need to solder those together. We could make them a little shorter, get them a little closer maybe. I think that's going to be fine right there. So let's get our soldering iron. And here it is. We got some solder. And we'll get the wires touching there. Let the blue wire be a kickstand, hold it in place. Get old Mr. Weller heated up here. All right. All right, that looks good. So now we've got our first connection made. Again, we've connected B1 to A2. You can see that connection there, I hope. So we've connected the green B1 to A2. All right, now, you know, the antenna line's good there. Now, C1 goes directly to the center conductor of the coax. So we're gonna bend this around just a little bit just to get it out of the way. And this is going to go, this one here is going to go to the center conductor of the coax, just like it says right here. But we need to connect B2, which is the green wire here, to it. So somewhere about right here, I'm going to have to cut these back. Again, I did make them a little long intentionally, make sure I had enough to work with. And I'm going to leave the yellow one longer and cut this one back a little bit. Let's cut off about 1 inch. And then we need to strip this back about 1 inch also. That's what I did on the other one. And get that insulation off. And get some off down here on B2. Doesn't have to be as much here. All right, so we got B2. And I take my needle nose and I roll a little hook in it like that. And what I do is I bend it up, I hook it over. So we've got B2 hooked over C1. And then I'm going to just crimp that down a little bit. Doesn't have to be real tight, but I like to have a little mechanical connection there. And then we'll solder that. Okay, got a good solder connection there. And we're almost through where we can connect this to a resistor and do a test to see if it's really a 9-to-1. So let's trim off insulation here and here. The C2, which is this bottom blue wire, will go to ground in the shield of your coax. So both blue wires attach to your coax. This one attaches to the center conductor, as shown here. This one attaches to the ground, which is here, which is also the shield of your coax. So we'll take off that little bit of insulation, and we're ready to, well, got to do that one. Got to do them both. All right, now, and we have, get that out of the way, turn it over so you can have a little contrast here. We should have 2 identical 9-to-1 UnUns, okay? Only difference is just the length of the wire a little bit, but other than that, they're virtually identical. You can see the windings are tight against each other here. They're pulled pretty tightly. I don't see any gaps. Like I said, the centers, because of the diameter of the toroid and the thickness of the wires, they're going to kind of touch like that. And I think that's going to work. So I've already tested this one. I know this one works. Let's test this one. Okay, what I've got is I've got 3 resistors here. I don't think there's such a thing as a 450 ohm resistor. So I put 3 resistors in series that add up to approximately 450 ohms. So let's see what it does add up to. Got my ohm meter here. See if it'll clamp on the wire there. Clamp on the other wire here. 457.7. That's the antenna itself probably won't be that close to 450 ohms. So 457.7, 457, 458 ohms, that's close enough. So where does this connect? Well, it needs to connect across the antenna lead. Remember here what we've got. The yellow is the antenna lead, and the other end needs to go down here on the ground. So let's, I'll put on one end at a time, and then we can test it. Get a little solder on here, make sure we got a good connection. See, it's already wanting to come off mechanically. All right, got that end soldered on. And then we'll put this other end on. And there we got the other end on. These resistors, what they do is they simulate the load of an antenna, okay? So what we need to do now is get our NanoVNA and connect it across these two. Because these two, the blue and the blue, is where your coax connects. So that should be 50 ohms, and this is 457 going through these resistors. And we have our NanoVNA here. So what I've got is I've got a little homemade alligator clip adapter. I took a little piece of coax here that had a SMA connector on it, and I cut it off, and then I put the 2 alligator clips on there, one to the shield, one to the center conductor, as you see here. So we'll connect that here, and we'll connect that here. See if we can get this where we can see it all. Let's turn it on. So SWR is not the critical measurement here. What we're wanting to see is resistance. So let's turn on another trace. So let's go to display, trace, and let's see, which one was that? All right, there's resistance, trace 3. And that's resistance. Well, what you may be able to see right here, we're currently at 1 megahertz. Of course, that's down outside the band. Let's go up to 1.8 or thereabouts. That's 1.797, as close as I can get on this particular scale. I'm going to turn off this SWR trace for right now. Let's concentrate on the resistance. Okay, we got 49.33 ohms, and that's mighty close to 50. And as we go up in frequency, that resistance goes down. Here at, let's get up to 14 there. There's 14,267, and we're at 43 ohms, basically 42.9 ohms. And then we'll go on up to 10 meters. And there's the start of the 10 meter voice band, 28.332. And we're at 30.4 ohms. You say, well, that's not 50 ohms. Well, you got to realize anytime you've got what's considered an LC or an RC circuit, you're going to have a reactance, and it reacts differently at different frequencies. So it's not practical to expect it's going to be the same resistance all the way across, but you wanted to get it into a tunable range. And anytime you're using a 9-to-1 with a random wire antenna, you're going to need a tuner, because a random wire antenna, what defines it as random wire is that it's not tuned to a primary or a harmonic of a frequency that you're going to be using. And so it's a non-resonant antenna. So you've got to have a tuner in order to make it work. So this is within a tunable range. We'll get into that in our next video when we actually build a random wire antenna. I'm planning on building a 41-foot random wire antenna. You're going to want to tune in for that. It's going to be kind of a different application. Not an original idea, but my spin on it. So hope you come back and watch that one. So here we've got our 9-to-1. It's doing the resistance matching from 450 ohms here on the antenna connectors to 50 ohms here on the coaxial connectors. So it's doing what it's supposed to do there. Now what we're going to do is connect these two back to back. We'll be able to look at our insertion loss. So stand by while I take the resistors off, and then we'll connect the two together, and I'll show you what they look like once they're connected together. Okay, we've got our test rig set up now, and I'll go through it briefly here. We've got the signal be coming out of the NanoVNA. You notice this connector, the screws are on the top, okay? And over here is the positive connector, and this is the negative connector. Well, in order to make the connection easier, I turn this one upside down. So on this side is the negative connector, and I've got the two negatives connected together, and I've got a common wire coming off to what is the ground wire, or will be going to the coax shield on the UnUn. Okay, I've got the two antenna leads, the yellow leads, connected together. And then the center conductor, which is C1 and B2, which is right here, C1 and B2, and C1 and B2, they're going to the positive connectors on each of these. Because the positive's here, because this one's right side up, and because this one's upside down, it is on this side. So that's how we've got our test rig set up. We have the NanoVNA set up in log mag, S21 log mag. And what the S21 means, it's reading it from S2 or port 2, and it's sending it on port 1. So it's sending a signal out, it's going into this UnUn here, coming out on the antenna and the ground connector, and going into this UnUn here, and coming back around and going into this lead here. So that's the connection. All right, so log mag here looks extremely good. Here we are at 28.332 megahertz, and we've got an insertion loss of negative 2.09, 2.1 dB. That's through 2, though. Remember, we have to divide these by 2 because we're going through both of them. So the insertion loss of one of them is going to be half of that. So 1 dB insertion loss. So that's very good. And if we go down here, let's check it at 14. There's 14,340. And here we have 272 millidBs. That's the equivalent of 0.27 dB for 2 of them. So cut that in half. 0.135, I believe it'd be correct or very close, 0.135 thereabouts dB insertion loss. And our resistance there is 42 point, I can't tell if that's a 0 or an 8, I'm sorry. 8. 42.8 ohms. And we'll come on up. Let's get around 3.8. All right, so there we are down in 80 meter band, and we're reading about 48.6 ohms and 0.19 dB insertion loss. So everything's checking out very well. This is a 9-to-1 UnUn, and this is what you would use for a random wire antenna. And there may be other antennas that are in that same resistance or impedance range of around 450 ohms. This will step it down or match it to 50 ohms for your radio or another device. Hopefully this has been helpful. I've learned a lot in building these. They're not as complex as they may seem. Hopefully this chart will help you. And one thing I wanted to point out about this chart, these dots indicate where there's connection between wires. As you can see here, we've got a connection to the antenna, we've got a connection to the center of the coax, connection to the shield, and connection to the ground or shield here, as well as C2. But right here is the main exception, where there's no way to get this to here without crossing over or under this wire. But there's no connection here. There's no dot here. And that's the big difference. I want you to realize there's not a connection here between B1 and C1. B1 goes underneath C1 in order to get to A2. That's the reason for the dots. But hopefully this will help. If you got any questions, comments, put them down in the comments section below. I'll try to answer them if I can. If I can't, I'll tell you I can't. Also, give me a thumbs up. Like the video. Subscribe if you haven't already. If you can, throw a little support my way through the Buy Me a Coffee link down below. Hopefully you enjoyed this. This is Kilo Mike 4, Zulu Kilo Bravo, saying, have a blessed day.